All right, let's evaluate this limit. We have limit of 3x squared minus x on x as x approaches to 0. All right, now when evaluating questions involving limit, so we have to first of all simplify the expression to its simplest form before putting in the limiting value here. So what I'm trying to say is that if we plug in 0 now, this side will be 0 to be 0 minus 0 over 0, so which is not possible. Okay, so what we are going to do here is to simplify this expression before putting in the limiting value here. Okay, so what we will do here is to factorize x out on the numerator. So this side will be x out. So I will left with 3x minus 1 on x. So this one will cancel this. So I will left with limit, okay, of 3x minus 1 as x approaches to 0. So we can go ahead then plug in the limiting value here. So which will be 3 times 0 minus 1, which is negative 1. Therefore, limit of this function as x approaches to 0 is negative 1. All right. All right, let's evaluate this limit. Now, if we plug in negative 1, this side will be 0. So to make this not possible, that is undefined. So we need to simplify the expression to its lowest term. So x squared minus 2x plus 3 is a quadratic factorization. So let's write the factors. Okay, so x squared minus 2x plus 3. So we have 3 here. So let's find the factors of 3. So we have to find two numbers when we multiply them to give us 3, but when we add to give us the coefficient of x. So we know 3, 1, 3, but what is here is minus 2. Okay. All right. So we have x squared minus 2x minus 3. Okay. So we have 1 times minus 3 here. So let's find the two numbers when we multiply them to give us this, but when we add to give us negative 2. All right, we know 3 times 1 is 3, but this side is minus 3. So minus 3 times 1 is minus 3. Minus 3 plus 1 is minus 2. So we are free to go. X squared minus 3x plus x minus 3. X out, x minus 3. So plus 1, x minus 3. So we have x plus 1, then x minus 3 on x plus 1. Okay. All right, so going forward, this one will cancel this. So I will leave it x minus 3. So I can go ahead and plug in the limiting value here, which will make this one negative 1, negative 3, as the result to be negative 4. So the result for this one is -4. As simple as that. Let's evaluate this limit. So we have limit of x squared minus 2x minus 3 as s approaches to 1. So anytime you are asked to evaluate a limit that is of a linear form like this, so just go straight to the point by putting in the limiting value. So this one is straightforward. So we have 1 squared minus 2 times 1 minus 3. So we have 1 minus 2 minus 3. So we have 1 minus 5, which is -4. So the result for this is -4. Okay, so that's that. All right, let's evaluate this limit. Okay, so let's check. If I plug in -3, this side will be 0 and this side too will be 0. So it will be 0 over 0. So it's not possible. So let's reduce this expression. We know the numerator sound like difference of two squares. So I can go ahead and say x squared minus 3 squared on x plus 3. Okay, so I can say x minus 3 x plus 3 on x plus 3. Remember, a squared minus b squared the same as a plus b, a minus b. So this one will straight away cancel this. So I've left x minus 3. So we can straight away plug in the limiting value here. So we have -3 minus 3, which is -6. All right, let's evaluate this limit. So if I plug in -1 here, this one will be 1. Okay, -1 0, and this side also go to 0, so to be undefined. So let's arrange this one well. We know x squared minus 1 the same as x plus 1 is the difference of two squares, x minus 1. So this side will be x plus 1, then x minus 1 on x plus 1 here. Okay, so we can do cancellation here, which will be x minus 1. So the limiting value here is -1. So once I plug in, I'll get -1 minus -1, which is -2. So the limiting value here has given the expression to this. All right, so we are given limit of a function for x squared minus 25 on 2x minus 5 as x approaches to 5 on 2. So if I plug in 5 on 2 here, this side will be 5, which will be 5 minus 5, which the expression will be undefined here. So let's reduce this. Okay, now let's adjust this, okay, and that, because we can get difference of two squares here. So we can say 2 squared x squared, okay, minus 5 squared on 2x minus 5. Okay, so let's go ahead, and now in case we're given x raised to n, t raised to n, the same as xt all raised to n. So I can say 2x all raised to minus 5 squared on 2x minus 5. Okay, all right, so I can go ahead and write the numerator as 2x minus 5, 2x plus 5 on 2x minus 5. Okay, so we can do cancellation here, which will be left with 2x plus 5. So the limiting value here is 5 on 2, so we have 5 on 2 plus 5. So this one will cancel this. I will leave it 5 plus 5, which is 10. As simple as that. All right, let's evaluate this limit. Okay, now let's reduce the numerator and the denominator. Okay, because if I plug in 2 here, this side will be 0. Okay, so the numerator is a quadratic expression. Okay, so let's see how to reduce it. So x squared minus 7x plus 10. So let's pick 10 here and find two numbers when we multiply them. So we have 5 minus 2 here. So x squared minus 5x minus 2x plus 10. So x out, x minus 5. Okay, and I'll pick negative 2 here, x minus 5. So x minus 5, x minus 2. So in place of the x squared minus 7x plus 10, I'll put x minus 5 and x minus 2 on. So we can write the denominator as x minus 2, x plus 2. So this one will cancel this. So I'll be left with x minus 5 on x plus 2. So with this, I can plug in the limiting value. So I can go ahead. So I'll put 2 here, 2 minus 5 on 2 plus 2. So we have minus 3 on 4 as the answer. All right. All right, let's evaluate this limit. So we have limit of a function, okay, with numerator 9 minus x on 3 minus x. As x approaches to 9. So if I plug in 9 here, this side will be 3. So 3 minus 3 is 0, which make this one undefined. In the numerator here too, if I plug in 9, it will be 0. So we want to reduce this, okay? Now the only way to reduce this one is to rationalize this, okay? So I'll pick the conjugate of the denominator here as 3 plus root x, okay, plus root x. So we have the numerator as 9 minus x, then 3 plus root x. But the denominator is a difference of 2 squares. So when we're given a squared minus b squared, the same as a plus b, a minus b. So I'll pick the one with the minus. 3 squared minus x squared. Okay, so I have 9 minus x, 3 plus root x. Okay, on. So this side is 9, and this one will cancel the root sign, minus x. So what do you see here? This one will cancel this. So I'll be left with 3 plus root x. Okay, so the limiting value here is 9, so I can go ahead. 3 plus, so the positive square root here will be cos 6. Okay, all right, let's evaluate this. Okay, now if I plug in 3 here, it will be 9 plus 7, 16, that is 4. So 4 minus 4 is 0. Then if I do same to this side, 2 to be 9, which will make this one go to 0 over 0. So let's reduce this by rationalizing this. So I'll take the conjugate of the denominator, x squared plus 7 x squared plus 7. Okay, all right, so we have the numerator as 9 minus x squared 4 plus. Don't be in hurry to expand the numerator because it will by all means cancel out, so don't expand the numerator. Okay, so the numerator here is a difference of 2 squares, so this one squared minus this one squared. It's like saying x squared minus y squared, same as x minus y, x plus y. So we have 4 squared minus x squared plus 7 all squared. Okay, all right, so I have 9 minus x squared 4 plus square root of x squared plus 7 on. So we have 16 minus, so this side will be very careful here because this negative is affecting this, so I'll introduce bracket. This one will cancel this, so x squared plus 7. Okay, so which will make this side behave like this. So we have 9 minus x squared, then we have, sorry, let me use this side. We have 9 minus x squared 4 plus x squared plus 7. So we have, so this side will be 16 minus x squared minus 7. So 16 minus 7 here will be 9. So we have 9 minus x squared. So let's observe something here. So we can do the cancellation. Therefore, I'll be left with 4 plus x squared plus 7. So what's the limiting value here? 3. 3 squared. 3 squared is 9 plus 7 is 16. So this side is 4. So 4 plus 4 is 8. Okay, so the answer for this one, okay, is 8. All right, let's evaluate this limit. Okay, So if I plug in 1 here, it will be square root of 4. So this side will be 2. So 2 minus 2 is 0. So which will make this undefined. So let's reduce this by rationalizing. So I will take the both numerator and denominator by the conjugate of this. So we know the conjugate. I will just change the sign. So we have this same thing here. Okay, so I have my numerator as this. So the denominator will be difference of two squares. So I'll focus on the one with the minus. So I'll square the first term, then do same to the second term. Okay, so my numerator, sorry, 1 minus x, 2 plus this. So we have 4 minus, so this side will be, let me introduce bracket, x plus 3. So I have 1 minus x so we have 4 minus x minus 3. So 4 minus x minus 3 will be 1 minus x. So we have 1 minus x minus x. So we can do the cancellation. This one will cancel. So I will have it 2 plus 2 plus x squared plus 3. So the limiting value is 1. So 1 squared is 1 plus 3 is 4. So we have square root of 4 as 2. So the answer is 4. Okay. All right. Let's evaluate this limit. Okay. So we have limit of a function. Okay, with fraction x cubed plus 1 on x plus 1 as x approaches to -1. Okay, so if I plug in -1 here, everything will be undefined. So we need to reduce the expression to its lowest term. All right, now let's observe some expansion here in case we're given x to the power 3 plus y to the power 3. Okay, the same as x plus y times, so we have x squared minus xy plus y squared. All right, so can we write the numerator x cubed plus 1 cube? Yes, on x plus 1. We know 1 cube is the same as 1, so I've done nothing to this. So let's go ahead and then expand this one. So we assume x is x, then y is 1 here. So we have x plus 1. Okay, so we have x squared plus x times 1. Okay, so sorry, minus x times 1 plus 1 squared, that is 1, on x plus 1. All right, so this one will cancel this. I'll be left with x squared minus x plus 1. So we can go ahead and evaluate the limit here. So we can now plug in the limiting value that is -1. So we have -1 all squared minus 1 plus 1. All right, so we have 1 plus 1, so plus 1. So the answer is 3. All right, now let's use another method. You can choose to, differentiate the numerator here and put the result down and do same to this. The answer will come. That's another alternative. Okay. All right, let's go ahead and evaluate this limit. So we have x cubed minus 8 on x minus 2. So as x approaches to 2 here. So let's focus on the numerator. Now, when you are given x cubed minus y cubed is the same as x minus y, okay, times you have x squared plus xy plus y squared. So let's observe the numerator. Can we adjust this so that it obeys this? Yes. Now we know 8 can be written as 2 to the power 3 here. Okay, so we have x minus 2. Now what are we seeing? We are seeing x cubed something to the power 3 minus something to the power 3. So we have x minus 2 and we have x squared, okay, plus xy, and then we have 2 squared, okay, on x minus 2. So we can do our cancellation, which will be left with x squared. Now remember, sorry, here this side is 2, not, so it's 2x. My y is 2, so 2x. Okay, so we have x squared plus 2x plus 4. Okay, so the limiting value here is 2, so I can go ahead and plug in 2. 4 plus 4 plus 4, so we have 12. All right, that's the answer. All right, so let's consider this limit. Okay, now this one is limit at infinity. Okay, so to evaluate the limit of a given function as x approaches to infinity, we always divide each term in the function by the x with the highest power. Okay, so considering the function here, so the one with the highest power is x squared. Okay, so to evaluate this, we need to divide through all the terms by the highest power here. So I'll get x squared over x squared minus x over x squared plus 1 over x squared on x squared on x squared plus 2 on x squared. Okay, so this one will cancel. So this one will move one of the x's here. So this side will go. So I have 3 minus 1 on x squared plus 1 on x squared on 1 plus 2 on x squared. So limit to infinity, my x here will tend to 0. So I will have 3 minus 1 on 0 squared, 0, 0 squared, 0, 2 on 0 squared, 0. So everything on 0, this side will also go to 0. So my final answer will be 3 on 1. So which is 3. Alright, let's consider this limit to infinity. So alright, let's evaluate this. Okay, now to evaluate limit of a given function as x approaches to infinity, so we divide each term in the function by x with the highest power. So we have x to the power 3 as the highest power here. So I'll divide each term by that. So we have this x cube, x cube, x cube, x cube, x cube. Okay, so this side will go. This side reduce this to 2. So this side will go. So I'll be left with 2 minus 7 on x squared plus 3 on x cube on 1 plus 2 on x cube. So to infinity, x will tend to 0. So we have 2 minus 7 on 0 cube, 0, 3 on 0, 1 plus 2 on 0. So 0, 0, 0. So we have 2 and 1, which is 2. Alright, let's evaluate this one. Okay, now you can watch my previous video to get more information about how to evaluate limit to infinity. Okay, so just as we said, we divide each term for limit at infinity. We divide, okay, each term with x with the highest power. So we have xx, so it's straightforward. 3x over x, x over x plus 7 on x. Okay, so this one will cancel. So we have 3 on 1 plus 7 on x. So to infinity, this one will tend to 0. So I'll plug in 0, 3 on 1 plus 7 on 0. The same as 3 on 1, which is 3. Alright, so if f of x equals to this, so we have 3 given functions here with their range given. Okay, so the first one, we have 4x minus 7, 4x greater than 3, and we have x squared minus 3, where x lies between -2 and 3. Then we have the third one, f of x, 2x plus 3, if x is less than -2, so 1. So f of x got 4x minus 7, 2, f of x, x squared minus 3. Then we have f of x, 2x plus 3. Okay, the question is, evaluate the limit of f of x as x approaches to -4. So where can -4 fall? Okay, so looking at the first one, x is more than 3. So x is greater than 3. So negative 4 doesn't fall here. And the second one too, negative 2 to 3. X lies between negative 2 to 3. So negative 4 is outside the range. But for this, x is less than minus 2. So we have minus 3, minus 4. So negative 4 is in this. Therefore, 2x plus 3, this one is the function. So my function here, so this one will be limit as x approaches negative 4, 2x plus 3. So just plug in the limiting value. Since this one is linear, minus 4 plus 3. So we have minus 8 plus 3, which is minus 5 as the answer. All right. All right, let's evaluate this limits together. Okay, so we are given limits of a function, okay, as x approaches to 2. So we have x to the power 4 minus 16 on x squared minus 4. Once we plug in the limiting value, this one will tend to 0, to undefined. So we need to reduce this expression. But how do we do it? Okay, so let's change the numerator to difference of 2 squares. So we can write x to the power 4 as x squared or squared, because in going back 2 times 2 is 4. So minus, so 4 squared is also 16 minus x squared minus 4. All right. So we can say x squared minus 4, x squared plus 4. So we have x squared minus 4 here. Okay, so what do you see? This one will cancel this. So I'll be left with x squared plus 4. So we can now plug in the limiting value. 2 squared plus 4. So we have 4 plus 4, which is 8 as the answer. All right.